meeting is being recorded.
Right, well, obviously, good morning. Thanks for joining me today. So today's subject is we're going to be talking a little bit about infrastructure management, specifically infrastructure as code. So what this effectively means is we're going to provide some automation around the provision of our cloud resources. So we talked a little bit yesterday and sort of introduced you guys to the different cloud consumption models. And at some point, your teams, your engineers, your developers, your ops team are going to have to start creating environments within the cloud infrastructure. And obviously, there's a number of ways in which this can be achieved. All of them have their different sort of benefits and drawbacks, and we'll cover some of those key elements first, and then we're going to dive into some demos. I'm going to introduce you to Terraform. So why do we need sort of infrastructure, code management? Again, as I said yesterday, cloud providers enabled us to rent compute, storage, and network, and they also exposed APIs to manage those assets within their data centers, usually through a web portal, and closely followed by sort of command line tools for sort of power users who were sort of using these environments sort of day in, day out as part of their normal sort of responsibilities. And I've just put a very simple example here for those who have maybe not used the sort of AWS API command line interface before. But this simple command just creates a bucket, an S3 bucket within AWS with a bucket name of example, and that's probably about the simplest example I can give you realistically of what a CLI call would look like with any of these cloud providers. They're all fairly similar. The APIs are vast. I mean, if you remember what I said yesterday about the AWS having over 100 services, every single one of those services would maintain and publish their own sort of subset of CLI commands that would be accessible through the primary AWS API. So, even if people with the best of memories would struggle to remember every single different command and parameter that you would plug into this. But obviously, like you said, it's not without its positives. Initially it was, it removed the logistics. You didn't have to go to a data center, configure hypervisors, and install virtual machines, and then configure the operating systems on top. You could do this from practically anywhere with an internet connection. So it completely sort of changed the landscape of, how teams sort of deploy and organize. Especially now, I think we can all appreciate the benefits of the role we perform and the fact that we can perform it from wherever we like in the world. It's quite a powerful concept. And the other part of this, it was scriptable. In the sort of early days of sort of infrastructure management, when the infrastructure grew to a certain mass, you'd find that you couldn't go into the portal and reliably manage it. So people would start scripting it, but the problem with that is that it's very imperative, and obviously you guys being developers, you'd be familiar with sort of imperative programming languages and sort of declarative programming languages. Imperative programming languages work, they're absolutely fine, but they are difficult to sort of grok. And what I mean by grok is just quickly understand what's happening within the code effectively. And obviously some of these scripts would become quite unwieldy. You'd create, let's say you wanted to create 100 EC2 instances, you would have to write bash scripts with for loops to create 100 EC2 instances. Then you would have to do the same for the security groups that were going to be on the network interfaces. Then you'd have to link them together, and quite quickly those scripts can become quite useful but difficult to maintain, and difficult for anybody new joining the team to sort of grok and understand what the infrastructure actually looked like. And secondary to this point is that manually provisioned infrastructure this way had a sort of inherent problem with simply with ourselves. Not to disparage intelligent people and the jobs we perform. We can fairly say that we're slow compared to a machine at performing tasks. We're error prone. It's very likely that given enough time, we'll eventually make a mistake, and that mistake could be catastrophic in nature when it comes to sort of business impacts. We're forgetful. Well, I certainly am. As I just said, if you've got 100 services in AWS Cloud, there's absolutely no way you're going to remember every single one of these services and all the parameters. And sort of, likewise, if you may perform the same task repeatedly over a course of a year, but if you're only doing it once or twice a year, you're very unlikely to retain that information, right at the front of your memory perfectly. And you might end up performing the task just slightly different, So if you did something in a development environment, and then a few months later you did it in test, and then a few months after that you did it in prod, there's a chance that you did something different each of those times. And whilst on the surface everything was healthy, there might just be some subtle differences that you would not be aware of, and those differences would be lost. What would happen then in the future would be that if you did have a problem that was related to those differences, it would become very difficult to sort of track down and sort of troubleshoot. And lastly, like you say, we are quite sort of unique beings. We don't do things perfectly. Every time we do something, we tend to do it. Let's say, just repeating my previous point, we do things a little differently. And this is not good for infrastructure, where we want to understand things. We want to understand where they came from, why they changed, how they're going to change in the future, and what the current sort of state is. So infrastructure as code is basically a way of managing that infrastructure, large-scale infrastructure, decoratively. So you describe what you want, you submit it to a engine, and the engine then actually calls the underlying cloud provider sort of API for you. And there's multiple reasons or benefits why you'd want to do this as you start to move out of small scale cloud infrastructure, just a couple of EC2 instances running. When you start dealing with multiple regions, hundreds of potentially virtual machines, disaster recovery solutions, and integration of all the additional tooling and services that sort of the cloud providers layer on top of just the core sort of infrastructure resources. So obviously one of the first benefits is sort of repeatability, and what I mean by this is just going back to my previous example. If you say you want a web server in a dev environment and a test environment and prod environment, you can absolutely ensure that they are exactly the same in all three of those environments, because you have stated that this is the configuration, this is the instance type that I want, this is the block device volume that I want attached to it, this is the underlying operating system, these are the ports that I want to open. That is repeatable. You can take those collection of resource and configuration and just execute it multiple times against your different environments, knowing full well that the engine is going to be able to make that into the true state of your infrastructure. Secondly, visibility. Again, going back to the UI example, over time, engineers will go in, they'll make changes, those staff will leave the organizations, new engineers will come in. You absolutely have no visibility of the sort of heritage and what's happened in the past in order to sort of make contextual judgments about certain things in the future. And obviously having visibility of that, because infrastructure as code is code, it's version controlled. You've got, if you put it in a GitHub repository, you've got full audit capabilities, from the beginning of time to the end of time, as long as that repository lives around and that infrastructure lives around. Auditability, again, this is just a nice side benefit of using version control for your infrastructure as code. I mean, some organizations will work in very strict security environments and have to go through audit processes. And obviously this can facilitate, satisfying those auditors. Plus, if any, I personally don't like to work in a sort of a blame-oriented culture. Sometimes it's good to just be able to see who's changed something and the reasons for that change, and sort of go back and talk to somebody who says, oh, why was this changed? So again, this sort of leads nicely into troubleshooting. Say if you have an issue in your production environment, and then you go and have a look at your version control system, and you see that somebody's recently made a configuration change. Maybe they've changed a security group to block a port that a critical service was running on. Obviously, that would be completely visible because it's going through through version control. It's going through basically a review process effectively, and not unlike your normal software code would go through. And this sort of promotes catching errors early, as opposed to allowing them to get through to production environments where obviously it has business impact. Disaster recovery is a good one. Yeah. So if you've defined your infrastructure, your entire infrastructure set, and we have a regional outage in AWS, if you had to recreate all that infrastructure by hand, or even through the CLI, even with the scripts, that would take some time, and your confidence of actually getting that right would actually be quite low, because again, going back to the just inherent nature of humans being a little bit error prone, a little bit forgetful. So this just makes it easier. It's easy to basically just point the tool at a completely different region and provision all your infrastructure exactly the same again. Okay, there's a few caveats there. Typically, you have to sort of have some sort of failover at the DNS level, but this is expected. I mean, there'll be time for the DNS to propagate out towards your customers and clearing caches. But fundamentally, standing up that environment would be far quicker using an infrastructure as code tool. And portability, maybe not so important. A lot of businesses commit to a certain cloud provider, but some do want to be multi-cloud. And whilst the infrastructure as code tool doesn't make it easy, shall we say, to spin up an EC2 instance in AWS and then a Azure VM with the exact same specification, because the APIs are different. What it does allow you to do is to systematically go through all your resources in one cloud and recreate them using the other cloud's provider. And so you just check them off. It's a really good checklist. You haven't got to sort of scour through the UI portal to try and find all your resources that you need to make up the environment. So it sort of works in the same vein as a disaster recovery. It's a visual checklist for you to just sort of go through them all. And this is where I sort of introduced Terraform as a very popular open source infrastructure as code tool. It's developed by a company called HashiCorp, who are very well regarded in terms of their sort of open source sort of project suite. They have a number of projects. Terraform was sort of one of their early ones, alongside another tool called Packer, which is used for building machine images within your local environment, virtual environment, or cloud provider. And it uses its own configuration language called HashiCorp Configuration Language, or HCL for short, to describe your cloud resources. It's actually a superset of JSON, and then it got some additional support for some domain-specific language. And what I mean by that is it supports sort of some degree of variables, control loops, conditionals, logical operators, things like that. So it creates a rich ecosystem for you to sort of describe and maintain your infrastructure. What actually happens under the hood is that when you execute it, it builds looks at all the resources. It builds an acyclical graph, so a directed acyclical graph, or a DAG for short, and then it was able to create the infrastructure in the correct order. So no longer have you got to sort of work out that, well, actually, if I need to attach a security group to an EC2 instance, then I need to sort of create the EC2 the security group first. Then I can provision the EC2 instance and attach the security group directly in 2 API calls. If you were doing it manually, it would be 3 API calls, because you'd probably have to create them both individually first, and no guarantee on what order you would do that in. And then you'd have to attach them to the EC2 instance. And you'd also have to wait for the EC2 instance to be available as well for these sorts of things. So it abstracts a lot of the complexity out of orchestrating the order in which these resources need to be created. And finally, the output from Terraform is basically a JSON file. It's a state file. And I can show you that later, just as a gift. But typically speaking, you don't interact directly with the state file. You interact through the CLI tool. So this is just a very simple example that we have here of what a Terraform file might look like. It's prefixed with a .tf, and I've created a couple of resources in here, and I'm just going to very quickly sort of just explain some of the key points here. You can see that basically the DSL sort of it's sort of block scoping. So you'd be familiar with block scoping from sort of Java. So everything within the sort of the AWS AMI Ubuntu block is specific to there. It doesn't leak over into the AWS instance web block. You can see that the attributes are basically key value pairs. And we've got support for nested blocks. We've got support for your primitives, whether they're sort of Booleans or strings or integers. And you've also got some support for some more complicated types. So, arrays, maps, arrays of maps, or maps of arrays even. And there's a wide range of functions available to you within the sort of Terraform expression engine, which allow you to do some quite complex things if you need them. I tend to like to keep things simple as much as possible and try and remove those the imperativeness. I find things when they're sort of decorative like this, they're much easier for me to grok and sort of see what's going on with an infrastructure very quickly. When you start to introduce those sort of imperative controls, you know, like for loops and things like that, then it becomes a little bit more difficult for people to understand what you've done. In some cases, this is acceptable. There's definitely use cases, but I'm always sort of err on the side of caution, and I need a very good reason to use those things.
Then this Terraform is applicable for all kind of cloud services like AWS, Azure, Google.
Yeah,
It's just specific for AWS.
Relieved. You're 2 slides ahead, sir. I'm gonna show you now.
Okay.
So the life cycle of Terraform, so it is basically 4 stages. There's an init command which basically looks in your current working directory at your Terraform files. It downloads any of the dependencies that your workspace needs to be able to execute. Then it's a plan. So this is a nice stage where it evaluates your resources, evaluates your cloud environment, and then basically gives you a nice diff of what's going to change when you run the plan. So that's very good for operators to be able to see what's going on. The apply is effectively when you delegate to the engine to actually go and create the resources or change the resources. And again, when this comes back, then it'll update your state file. And then, you know, not something you use all the time, but certainly I use it quite frequently when I'm doing this sort of work, is that the destroy command will tear down all your resources. So it might sound a little bit destructive, but in certain environments like sandboxes, development environments, proof of concepts, it's really good, because if I had to spend 20-30 minutes every day clearing up all my resources around VPCs or Kubernetes clusters, it would be a huge waste of time for me. I know full well I can kick off a destroy in about 10-15 minutes. It's cleaned up any resources in my environment that might be costing me money. So yeah, while it's obviously not something you would use every day in production environments, so for non-production environments, it can be a really good cost saving exercise. You know, and you could do some interesting things like, you know, if you had a development account within AWS, you could run a scheduled job that at the end of the day, it would go through all your Terraform workspaces and shut them down and destroy the resources. So you're saving money on them. So, you know, it's not without its uses, but obviously just with a big asterisk by the side of it, say it's very destructive. And if you compare that to sort of the UI and the CLI approaches, you know, with the UI, you'd have to log into the portal. You'd have to sort of navigate to all the services, you know, for example, EC2 that make up your infrastructure. And a lot of these UIs, while they have sort of multi-step wizards to create, say, an EC2 instance or a VPC, you know, they take time to go through. They're slow. They're designed to be simple, or as simple as possible, and sort of help you through it. But they're not particularly quick in doing that. And plus, then they do a lot of stuff in the background for you, and you lose an element of governance and control. You know, it's very difficult to apply naming conventions, for example, when you use these wizards, because it generates certain resources in the background for you to make it simpler for you. And obviously the CLI, you know, the equivalent here is that, well, from creating an infrastructure point of view, it's okay. From changing an infrastructure point of view, it becomes very difficult, because a lot of the time you need to know the physical ID of the resource to be able to do the update. So changing and modifying infrastructure through the CLI becomes very, very difficult and sort of error prone, because you don't have that information at hand. You've got to find that information. Then you can't script it then, really, or not easily script it. So I'm just going to introduce you to some of the primitives within Terraform, and then we're going to get, should take a few 5-10 minutes, and then we're going to dive in. I've got a few demos to run you through, just to show you guys how it works. So you might have seen in the example a little bit earlier, no, we haven't got any variables in there. So most programming languages support variables, or sort of first class sort of primitives. Terraform is sort of no different. So I have to apologize, my styling's a little off on the slide there. I have to fix that. You declare a variable with a variable block. You give the variable a name. You assign it a type, so your primitive type, whether it's a string, boolean, integer, list, and you can also assign it a default value. One thing I haven't shown on here is that you can also give it a description. So that's really good for, again, for people coming to look at your infrastructure code and just understanding what the variable actually means and what it controls within the infrastructure. And then, like I said, just below that, then what we're using is the provider, which is a block I'll cover in a minute. We can refer to that variable just by using the var keyword dot and the name of the name of the variable. Effectively, this is a big improvement. So a previous version of Terraform, it's been rewritten recently, or at least the primary engine, which makes the using the expression language far more intuitive than it was. So it's a real big benefit for writing that code. So, Rajiv, just to answer your question, providers. So this is another sort of first-class concept within Terraform. Provider is basically an API client that wraps around some upstream API. It makes no discern between Azure, AWS, Google. Some of these are maintained by Terraform themselves, but there is a public registry of custom providers, so custom API clients that can so you can use Terraform to provision anything you like, provided that you can write a CRUD interface for it around the service. Then you can use Terraform to manage the resources within that service. Obviously, authentication notwithstanding and things like that. So yeah, absolutely right. There's an AWS provider, so that deals with uses the AWS SDK to make the API calls. There's a Azure provider which will use the Azure SDK to make Azure calls. And you just define them within your plan file about what providers you need, and that tells Terraform where to download them from effectively. And you can pin them to versions as well, so you're not accidentally pulling in changes. Again, you're treating your sort of build dependencies, if you like, no different to how you treat your build dependencies in a software development environment. You're bringing all of those sort of good practices into this discipline.
Okay, got it then.
So, seems to right. I've lost the slide, I'm afraid, guys. I think looking at that, just bear with me very quickly. I'm going to just fix that because it's got something important on it. There it is. My apologies. Yeah, so this is the slide we lost. Just going to go back very quickly. So just a quick point on environment variables or variables within Terraform. There's multiple ways you can set these variables. So the idea is to sort of not to hard code. And again, from a software background, we don't like to create hard coded variables. We tend to like to externalize those, so it makes our code really sort of portable. And there are sort of three main ways in which we can populate these variables from the command line. So most of these tools support environment variables. So you just set an environment variable here, prefix with a tf underscore var underscore and then the variable name. The CI has got support for passing individual parameters or variables, so -var, AWS region, EUS1. And it's also got support for passing entire files of variables. And these are just ini files. The file extension doesn't matter. They're just key value pairs. I mean, a Java properties file, in terms of the structure of it, would work exactly the same as well. So a quick question, and then let's see. Which region do you think here Terraform will run against? So I've got three different regions defined in three different ways, and the Terraform command at the bottom is going to be executed, and it's going to plan to run some to create some resources. Which region do you think it's going to run against?
1. EU
Okay.
West 1.
We're going to go run. No.
Yes. 2.
Two, yes.
Yes,
Nice too.
we do.
Okay.
So every just one thing to bear in mind, every tool is different. The variable precedence in all these tools is usually well documented, and in this case, the lowest precedence is the environment variable, and the highest precedence is what's passed into the var or var files. So var and var file is given equal precedence. However, the order in which they're specified on the command line takes it's sort of from the right. So whatever is furthest right is the one that's going to win out. So in this case, it's the value from vars.ini that's actually going to run against the plan. I wasn't trying to trick you, but it's every tool is slightly different. So those worth just making sure people understand just to check the precedence of these things, because they can have unexpected consequences. And yeah, and the other sort of main primitive I just wanted to talk about very quickly is the resource block. So if we just go back to our little example here, so the resource block here at the bottom, this is effectively our primary resource. You know, every single thing within our cloud environment is going to be represented by a resource block. As you can see, the resource block has got a resource type. So in this case, I'm using from the AWS provider, the AWS instance type, and I'm giving it a unique name as well. So in this case, I'm assigning it the name web. Go back. So names are unique within the sort of type and workspace. So for example, if I was creating, if I had a single workspace and I was using an Azure provider and I was using the AWS provider, and I created an Azure VM and a AWS EC2 instance, I could call them both web if I wanted to within the state tree, because it creates a tuple of the resource type and the resource name, so it would be unique within that workspace. One really important thing here is to remember that the DAG, so the engine that's managing the life cycle, and I've mentioned this earlier, it manages all the resource dependencies for you implicitly. However, there are certain circumstances and edge cases where Terraform wouldn't be aware of the order of creation. If you were using across different providers, there would be no way to sort of say to it, well, I need you to create this resource first in this provider, and then I'll create this one. Or at least it's unable to do that because it's using different APIs and it can't relate the two together. However, you've got control over that. There's an escape hatch where you can be explicit about, declaring your resource dependencies, and the engine will then make sure that resource A is created before resource B. So, it's not meant to use on a daily basis, but it's there as a sort of an escape hatch if your infrastructure needs it. And again, a really important point here with Terraform is anytime you modify a resource in any way, it's going to cause the engine to reconcile. And sometimes this might actually have unexpected consequences. So if you think about an EC2 instance that's got using a certain machine image version, if you update that machine image version, what will happen is that EC2 image is replaced, and you wouldn't necessarily have any control over that. So it's good to be aware of it, and good to know when you don't want things, what resources can be destroyed, and how to prevent those resources being destroyed as well. Data sources. So again, sometimes we want to pull data in from the environment, from our cloud environment, whether that's, so in this case, I've got a very simple example here where we're basically saying, give me the AMI ID of the latest Ubuntu Focal 20.0 server. It'll pull that into the execution engine, and it makes it available to you through the data property then. So you can refer to it using data.awsami.ubuntu, and you can plug that in. So just go back here. So you can plug that into your resource. So you've got that sort of cross. It basically creates a variable, or a static variable, if you like, that you can refer to be able to grab attributes about that particular resource. So in this case, we're grabbing the ID attribute of this resource that we've looked at. And again, it's just using the cloud provider's SDK to look these resources up by their sort of physical ID, or with a filter. In this case, we're applying two filters because we need to call the EC2 describe images API internally, and usually you give a filter to narrow down the results. Otherwise, it would give you every single AMI that exists within Amazon, which is usually a very expensive sort of call. And then output. So by default, everything is hidden in the state store. This is for sort of security reasons, really. On occasion you might get some sensitive information that might go in there, and there are ways of protecting that, which are probably covered in the advanced topics. But it's up to the sort of responsibility of whoever's building the infrastructure templates to expose the important bits of information that's relevant for the infrastructure. The state store can be quite verbose. Obviously, it's difficult to grok because of the size of the JSON. So if you're only interested in pulling out IP addresses for all your EC2 instances, then you can write an expression to basically go through the entire tree, pull out all the EC2 instances, and grab their IP addresses. And when you run Terraform output, it'll just list them out on the command line. And last, so I think it's probably a good time for a demo actually. So what I've done, and I do apologize because live demos sometimes do go wrong, and I do apologize if this happens. So I've created a little project here, and just to show you just sort of a default structure. It's heavily sort of influenced by the slides we've already gone through with the primitives. The way I like to do it is I like to separate my files out by the resource type. So I have all my data items within a separate file. I have all my outputs in another file. I list all my providers, all my dependencies in another file, my variables in another file. And then I create individual files for the sort of type of resource. So in this case, it's an EC2 instance. I've just called it ec2.tf. You'll see a lot of conventions where they just use main.tf, which is completely fine. I mean, it makes sense, whatever, for your infrastructure. You know, you start with main. If you end up with too many resources, break it out into logical layers. So I'm just going to show you some of these. So if we look at the variables file, we've got a single variable defined, AWS region, same as in the example. Providers, we've got an AWS provider, so that we're going to provision something in the AWS cloud. We've got some outputs here, which is the private IP of the EC2 instance that we're gonna produce. Let's get rid of that. And we've got some data elements that we're going to look at. So again, just from the same example, we're going to look up the latest Ubuntu image for our infrastructure. I don't ever recommend just blindly looking at the latest because they publish new versions over the time. And if you remember what I said earlier, it could potentially blast away your existing infrastructure if that's the case. And then the EC2 one, which is really our resource definition, it's exactly the same. So we're going to create a Ubuntu 20 EC2 instance with a T3 micro instance type, so the smallest. This qualifies as the free tier, and we're going to assign some tag attributes to it. So if we go back to, if you remember our life cycle, we've got a couple of different phases to run through. So first we've got the Terraform init. So this is initializes the state store. Obviously, I've run this previously, and it's pulled in the provider from HashiCorp for AWS at the version that I specified. We're going to run the plan. So in this case, obviously, some of you guys would have seen this before, but the AWS Vault command to the left, that is just for me to grab some temporary credentials from my AWS account, expose them to the environment that I'm going to be running the Terraform plan in, so I don't have to provide it with any credentials. Obviously, most people start off exposing their AWS credentials, and they would just be able to run Terraform plan. But obviously, in this case, what would probably happen is that it cannot connect to any cloud because it's got no credentials. Yeah, so I've got no credentials. However, if I had exported them, I could run it. We're going to run a plan now. And this is the sort of output you get. So it's nice and easy to read. It can be quite verbose again because depending on the size of the infrastructure you're creating, but it can be verbose. But you can record it, you can store it somewhere. You've always got something to refer back to. So you can see here we're going to create a resource. There's a little plus sign here. So we're going to create a resource. There's different symbols for changing and destroying. So we're going to create a new EC2 instance. We're going to use this image ID. So this is the image ID that Terraform looked at, given the filters. This was the only one. A lot of these things obviously are during the plan phase. We don't know what public IP it's going to get. We don't know what the instance state is yet because it hasn't been created. So this is just to tell you that these are dynamic values, and they will be populated in the state store after you run the apply successfully. There obviously are things that it does know because they're defined within the plan file. So for instance, I've added some tags. So we're going to add a name tag with hello world on it. Nice and easy. And obviously, because this is a web resource, it's not just the instance, it's the block devices that are attached to it. So the disks, you know, the API documentation will tell you what the default values are. So in this case, it'll probably create it'll create a block device of a default size and attach it to the EC2 instance that we can use. It'll also attach an ephemeral block as well. And also a root block as well, where the operating system is going to be hosted, and a network interface. So it's got some network connectivity. So we could start opening ports on it and allowing traffic to flow. And again, here just at the bottom, you've got a bit of a summary. So obviously, if you don't want to look at the entire output, you can just see, well, I'm going to add one resource, nothing to change, nothing to destroy. And the outputs is going to be known after apply. We're going to output the instance IP address. So what I'll do now, I'll just run this through the apply phase, and fingers crossed, we don't have any connectivity issues. So it basically goes through the exact same process again, prompts you to make sure that you want to perform these actions, because what I've done here is I run a plan, then I've run an apply, which runs a plan again and then executes it. There's a very small chance that something changes within that period, and the expectations wouldn't be the same. What you can do is when you run a plan, you can output it, and then you can plug it into apply as an input and say, so you always know when you run it, when you're applying a plan, you're not leaving it up to that very small chance that something might change in that interim period. But in this case, for demonstration purposes, I've just assumed nothing's going to change. It's a very simple environment. So yes to that. And you can skip this. So in a CI environment, there's a flag you can give the CLI that basically auto approves it. So if you had continuous delivery of your infrastructure in certain environments, you could script that and automate it as well. So you wouldn't have to have a human constantly just answering yes or applying infrastructure changes. This would all be built in. So obviously it's just an EC2 instance. It's a micro instance type. So it's very quick to provision. We're done. We've added a resource. We've got an IP address. I can't remember if I haven't attached any SSH keys, so we're not going to be able to SSH onto this box at the minute. However, what we can do is show you in here. So if you go back to our example, because I haven't specified any var files or environment variables on the command line, it's going to create it in the default. So if we look at the variables file very quickly, we can expect the resource to be created in US East. And there we go. So it's just in the initializing phase. We've got our IP address. If we go and have a look at the tags, we've got the tags that we've assigned to it. And it seems a trivial example, but obviously I think it demonstrates something quite powerful, you know, about what we've just done. Go back to here, and once it's finished, we can make changes to it. So let's just still VI 2. Let's add another tag maybe. So we'll just say through to bar. We're going to plan that again. This time it should have some change elements next to the output. So you can see here now we're not creating the resource. The output is much smaller. The resource is being changed, but it can be updated in place. So it's not going to be replaced because all we're doing is just adding a tag, an additional tag to the resource. We can apply that very quickly. It should be almost instantaneously. Done. And if we just go into the console here, refresh the page, we should see that our EC2 instance has new tag. There we go, nice and easy. And to get rid of the infrastructure, we could just use the destroy command, as I said earlier. And this time I'm going to use the auto approve, so it's not going to prompt me to whether or not I want to do this, because I definitely want to do this. So you can see now we've got a little red dash by the side of everything, which is just going to show these are all the resources we're going to destroy. Summary at the bottom, nothing to change, nothing to add, one to destroy. So there are some timeouts here. I think Terraform by default has about like a 30-minute timeout, so it can run plans for up to sort of 30 minutes without sort of falling over. One thing to bear in mind, if timeouts are reached, that doesn't mean that it hasn't made any changes. All it means is it's got so far, and you would have to rerun the command to sort of complete everything. Ideally, we try to avoid that, you know, and avoid the scenarios where plans, you know, whether you're applying or destroying or updating fail. Through like I say, logical separation of the infrastructure, which sort of makes sense. But it's just good to know that if the command falls over at any point, it's made progress, but it hasn't completed everything. So it's always worth checking and rerunning the command, making sure it completes. So I'll just show you that the oh, there we go. Thought might happen at some point. Let me just refresh my token. So there we go, instance state running, it's gone. And if we look at what's been terminated, you can see that the instance ID that we just had, it's just there. So it stays in the console for a little bit. These do get tidied up from time to time, because as you're spinning up and spinning down machines, your console is going to get littered with instances that are historical. And AWS will clean these up from time to time, unless you specifically tell it not to, because it's in a terminated state. If you just wanted to keep the instance lying around, you would just move it to a stop state. But you would still be, it would just be there, it would remain in the console indefinitely. Right, back to here, and yeah, so that's your first plan effectively. You know, just to sort of overlay this with a little bit of context, the entire EKS cluster networking in the proof of concept, if I had to do that by hand, it would probably take me 2-3 hours every day to wire it all together, really, with all the security groups and things like that. It provisions in, I think, about 15-16 minutes, something like that. And to be fair, the majority of that is actually the EKS service provisioning a control plane for me. So if you're actually talking about all the other resources apart from that, it's probably less than 2 or 3 minutes. But if I had to go into the console or CLI, provision this by hand, create all the subnets by hand, wire, you know, all the route tables by hand, this would potentially take me a very long time. And, you know, I'd probably, if I have to do that every day to provision the environment and then spin it down, you know, it would probably take me 3-4 hours of my day doing that, which obviously is an absolute waste of time. So having tools like this, I can spin up my environment, go and grab a coffee. When I come back, my environment's ready to use, and I'm using my day efficiently. So what I want to do now is just describe some of the slightly more sort of medium features that you've got available to you at your disposal. I wouldn't call these advanced features, but they're useful to know about. So this really...
Lena, before that, can we go down to that your repo structure once, and where you just showed us the different TF files?
Yeah, what would you like to see before my...
Yeah, just the structure where you showed that different. So these TF files, does Terraform picks up automatically, or we mention it somewhere that it should pick ec2.tf for provisioning the resources?
Just from the working directory, that's it. It picks them up directly from the working directory.
Okay, using the tags.
Yeah, it does nothing from your point of view. It's you have 2 separate directories with 2 separate sets of TF files. You would just go into each of those directories and run your Terraform apply.
Okay, and it identifies using the tags specified in those TF files.
Yeah,
like
all it's doing is doing a wildcard search. It doesn't matter what you call the file; it will pick up any TF file and assume that it's got resources, whether they're data resources or their infrastructure resources or their outputs available.
Okay.
It will just use any TF file in the current working directory.
Okay. Now, can you open one by one using cat?
Yeah,
I'll just.
So we'll start with the provider, because that's obviously the top level. So
yeah. So this source and version, we need to remember that.
You can just grab them from the public Terraform registry. All you're doing is pinning your dependencies. So very much like you would do in a software environment, you wouldn't allow your dependency manager to pull in.
So this AWS is a kind of variable name, and source and versions are its values that we can pick up from the.
Yeah. Well, actually, let me just show you. Actually, probably quicker. Oops, no, it's definitely not it. So there we go. This is maintained by HashiCorp. This is the AWS provider documentation. Obviously gives you example usage. And then if you go into this, then it shows these are all the services that it supports. So you can dive into sort of EC2. You can grab the sort of like EC2 instance, wherever we are. There seems to be lots of them. TTT and being absolutely blind. I can't see the instance.
You can
E-
search
even
it.
for OS build, we need to check it from Terraform platform, right?
So the OS level is
Like
actually cloud provider.
AMI instance
Yeah.
and everything.
Yeah.
Yes.
So if you want to use AWS AMIs, then you can, because AMS build and publish them, and you can grab the latest version. If you want to build your own AMIs, then there's I haven't covered this in these sessions, but you can use a
Okay.
tool like Packer or EC2 Image Builder to build your own customized AMIs if you need them. But obviously that comes with its own set of additional responsibilities about maintaining and patching those AMIs. So always consider the operational impact of doing those before you sort of commit to doing them. But some people have to do them. If you have security requirements, you might have to install additional security software, SE Linux or AppArmor or something like that. And the base operating systems that the cloud providers manage might not give you the capabilities that you need. So it's always comes, something to do your research on whether or not it's sufficient for your needs. Let me just go back.
Okay.
So you're okay with that? Do you want me to show you the next one?
Yeah, so source and version is fine, and then provider AWS region is equal to var.aws region. So it is picking up from our variables file.
Yeah, absolutely. And it's basically instantiating. When you think in a code level, it's instantiating a new client. So it's doing, in Java, it's doing, new AWS SDK client. You're passing it some configuration details like the credentials and the region, and it returns an instance of the client. And at that point, then Terraform internally is just using that client to make the API calls on your behalf.
So for the region, if there are in the same zone, there are multiple regions, right?
Yeah, so if you wanted to use multiple regions, you can define. So again, what I said about resource naming, you can define multiple provider blocks and you can give them an alias. So you used to say, this provider block is EU West 1, create another environment block, EU West 2. And then what you can do then is when you create your resource, you basically pass the provider to the resource just to nudge Terraform into creating the resource in the correct region.
Okay.
Generally speaking,
and
though, in terms
where
of
are we? Yeah, sorry.
I was going to say, generally speaking, though, I tend to encourage people to keep all their resources for one region in a single workspace and don't tend to mix them, because it can, again, from a grokking point of view, it's just a bit easy to say, right, these are all my resources in EUS 1, these are all my resources in EUS 2. So that's my general. There are some cases where you do need to mix providers, but those are limited, and I tend to create very specific workspaces for that. They're very tuned to that specific purpose, and people don't tend to mess around in them too much, because once they're set up, they're set up for good.
Okay. And where are we using this provider now in our data or?
Yeah, so basically, so by default, if you've got one provider, you don't have to do anything. So if you go into EC2, it's that you don't have to tell Terraform that to create this resource. However, if you do, I'm trying to think if I've got an example in. I don't think I've got an example for that, multiple providers. I can show you actually very quickly. Let me just show you this. I don't know. I'm going to get back to the slides because bear in mind, I've got about 10 minutes left. And I do want to cover some flow control stuff. Let me just dive into this. So in the proof of concept, what we got here, look, is that you've got multiple provider definitions. So let's call it a hub and spoke model. We've got a hubs and we've got a hub account and a spoke account. And then I've created a couple of resources using a module to deal with the peering aspect. So you've got network connectivity across VPCs. And you can see here, whenever I'm, I can pass this provider's block effectively to the module or the resource, and I can basically give it a tag. So when we use the alias, it knows exactly where to create, which region we're going to be creating these resources in. This is a bad example because it's hidden within a module rather than a top level resource, and we haven't got to the module bit yet, but you have support to create as many of these as you like.
Okay.
Get rid of that. Let me just dive back into the slides. So yeah, so life cycle management. So here's a really good example. What I said earlier about you can have unintended changes. So if you make changes to your infrastructure, and it can have unintended changes, there's a life cycle sort of meta block, if you like, that you can apply to any of your resources. And it supports sort of three main controls. So you've got this create before destroy. So what this would do would be create a new resource in the cloud provider before destroying the old one. So if you wanted to say do a blue-green deployment environment, then you could do that with this feature, because what you would create let's imagine you were creating an auto-scaling group, which is a fleet of EC2 instances that are sitting behind a load balancer. What you could do is create a new auto-scaling group that is basically with the new version of the software on, and before you destroy the old one, the traffic flips over, you can prove it's healthy, and then the second one, the second stage, if you like, of Terraform will destroy the old auto-scaling group. So that would prevent you from having any downtime. You've got a prevent destroy. So if you're managing your managed services like your production environment, typically you would put this flag on things like your RDS database, just to make sure that once it's been created, the only way it can be destroyed is through the console, and then you can limit the chances of that happening by only granting certain trusted individuals the ability to admin privileges effectively to destroy your database, because nobody wants anybody accidentally destroying the production database. And you've also got this other meta flag called ignore changes. So in some cases, depending on how you're using the infrastructure, what you might find is that you want to be able to make changes to your infrastructure within the infrastructure's code, but you don't want Terraform to do anything about it. So what I can do here, to show you a very quick example where we're basically going to ignore the tags. So if I change the tags, it won't actually trigger any updates, and it'll show that within the console. So let me just pop back to full view mode. So we're going to go up. Where are we? Life cycle. The tree. What we got here is just a simple TF file. In this case, I have. Oops, I'm missing a couple of that. So no primitives, and we'll just grab the variable. We'll grab the data as well, because we need to look at that, and we probably don't care about. We'll grab the providers as well. Nope. CP. So the guy should have enough there to init and plan. So let's have a look. I'm going to plan quickly. So yeah, again, we're going to do the same again. We're basically going to create a EC2 instance with some tags attached to it, and then I'm going to mutate the tags and show you that it doesn't have any effect because of this metadata argument. Are you guys okay to just stick around for another sort of 10, 15 minutes? I've just got one more section to cover.
Yeah, Dana.
Cool.
Sure.
Okay, great. So we've created that resource now. Let's just look at our EC2 instance. So we've added the lifecycle meta argument here, and we're telling it to ignore the tag attribute. So this. So in theory, if I add well, this is probably not a good example really, because you probably would never want to ignore the tags that you're applying, because tags serve a purpose if I run a plan, but it's a good way of just demonstrating it very quickly. It should show there are no changes required to your infrastructure, because any changes to that specific attribute are being ignored. So there we go, no changes to your infrastructure. So it can be very useful in certain scenarios when you're developing reusable modules and things like that, because you may want to prevent certain values from triggering accidental resource creation or replacement or anything like that. So it definitely has its uses in sort of more advanced use cases, effectively. And then the last couple of things I wanted to cover was flow control. So, as I said earlier, it's a superset of JSON, HashiCorp configuration language. It supports control loops, logical operators, and expressions. together they can become very powerful within that environment. So yeah, just a very quick example. I've got a variable that's a Boolean flag that I've called create web. The default's to false, and here then I use this special count resource, which is applicable to any resource. So it doesn't matter whether it's an AWS, Azure, Kubernetes. It's just part of the Terraform configuration language. I can use a ternary operator to basically say, well, if the variable is true, we're going to create one of these. Otherwise, we're going to create 0. And that's basically a very simple if-else statement in a decorative language like HCL. And let's see, we should be able to do a little example for this, provided again I've copied everything across. So let me just tree that. So I've got my data. Yeah, that looks fine. So by default, we should say cats. Okay, I'm just going to comment that out a second. I don't want that running. Give it that sec. So it's this repository. So notice actually I didn't specify the provider here in this particular one, and what Terraform's done is gone and picked the latest provider, because it knows the resource type. It's gone and grabbed the latest one, which might not be always what you want. I always suggest you lock down version numbers with things like this, because from time to time versions can change and they can have unintended consequences. So no different how you treat your sort of software in that regard. So if we do a quick plan, you should see that no resources are being created. So no changes to your infrastructure. And in this case, now I'm going to pass in a variable, create web. Whoops. That's true. And then plan. Oops, where's going to be? Oh, no, there we go. What are you doing now? I'm wondering if it doesn't like the quotes because I'm using ZHS. What's going on here? Oh, something's being a bit weird there. I use a different shell, and sometimes I find it behaves slightly weird when I don't use quotes around things. Why are you being very weird? Oh, it's single quotes. It's gonna do me on, which is lovely. Why are you doing that then? It's very, very, very strange. Oops. Okay, well, it looks like my console's not going to do that very well. So what I will do, just to change this, best laid plans and all that, we'll go into the conditional. Just going to change that to true. So, and now we can run a plan. It should work. So there we go. That's just an example of using a simple control loop to conditionally create a resource. I won't actually create it because we've sort of been through that already. And if I just comment these out, and we'll look at the second use case. So loops, again, we've got full support for loops. So in this case, I've created a variable, number of instances, given it a type of number and given a default value of 3. I've created a resource called web loop, and I've used, again, the same count attribute to basically tell Terraform to create 3 of these. And you've also got sort of access to sort of special variables doing the run. So in this case, what I'm doing here is I'm just giving the an index tag to show which number is it. So what Terraform will do is it'll count through 0, 1, 2, 3, 4, 5, and it'll assign the tag or the index number of the loop to the machine. And obviously it's 0 index like most other programming languages, so I'm just remembering to add 1, so otherwise we don't end up with a zero option. So you can see here with the outputs, we've actually got, so it's slightly different now, we've got a few more resources being created. You can see the index of each one. Yeah. And if we just apply that, oops, well, we're not doing that then. Oh, it doesn't like the fact that I've not given it a VPC. I don't know what's happened with this one. It's this particular workspace seems to be a little bit funny. Generally speaking, that should work. So what it might be is that in the region that it's been created in, what region did I put it in? Yeah, whatever the default region is, because I haven't put a provider in there, the default region. So in AWS, when you create an AWS account, what you find within VPC, you get a default VPC. So you should never use the default VPC. Typically, I clean them up because I don't want people to use them. And you probably find whichever region. So when we were creating resources in US East 1, we had a default VPC available to us, which is here. I very much suspect in the region that we're working in, the default VPC has sort of been destroyed. So this is why it cannot find, or the plan's failing, because I haven't specified a VPC ID. So again, one of the nice things about your code editors, you can get code completion, links to documents, things like that. You can specify the sort of all the attributes through here. You've got auto completion, and one of those attributes would be basically telling AWS where to provision that machine and what network. And because there's no default VPC available, it has nowhere to provision it. So I would have to go through the process of creating a VPC. I don't think that's necessary. I think everybody, fundamentally understands what we've done there, and we've created multiple instances, and every instance within that loop is going to end up with a tag, 1, 2, and 3 in this case. So pass over that. And lastly, before we sort of finish up, I just want to talk to you very briefly about modules. So eventually, we're going to see patterns within our infrastructure. We want to create a public-private VPC. We want to create an EKS cluster, or we want to create a serverless application and all the, the underlying services, queues, topics, logs, dashboards associated with it. When those patterns start to emerge, Terraform supports, code reuse through something called modules. It's nothing special, it's just a set of TF files that are in a subdirectory or in an external Git repository or external module registry that you can refer to. Again, similar to the providers, it's got an identifier, a name and a version. Or if you're writing your own, you can use a local reference to a module that's on the local disk. And this pattern, quickly becomes beneficial when you're working across multiple regions, working across multiple environments, and you want to build, say, a web stack which has got a database, application server, load balancer. You can package that into a module, and then you can just create it over and over again. So I'll just quickly show you. I could probably try. So what we got here in for that. So I've created a very simple workspace. It's got variables. It's got a VPC, a VPC.tf file, which is going to contain our VPC, and it's got some outputs. So in the outputs, you can see that I'm grabbing some of the outputs from the module. So again, no different to writing your normal plan files. You just refer to it using the module syntax instead of a resource syntax, because the resources actually live within the module. So it's obviously up to the module author to decide what the interface looks like, what configuration options are exposed and what outputs are propagated up within the workspace. You've got your variables. So in this case, I've created just a few variables that the AWS region, the name of the VPC that I'm going to create, the stage of the VPC, whether it's for test workloads, production workloads, and I've also got a variable for the CEDAR block, or the CEDAR indication. So that's going to give me a range of IP addresses that I can assign to EC2 instances that are provisioned into this VPC. And then to actually look at the module logic itself, or the definition of a module, follows exactly the same sort of syntax structure or block structure as all the other resources. It's just the module keyword. Couple of special ones here, similar to the provider, where you give it the source. So the source by default is the Terraform registry. The version is a published version available in the registry. And then you can plug in as many or as few of the attributes that you need. So they'll all have the sensible defaults, but obviously you would override these. So in this case, this particular module for a VPC asks for a namespace. And if you look at the variable definition, namespace is sort of like, again, just a logical grouping of these things. The stage is sort of analogous to our environment, where there's sort of dev, test, production, and the name is just a unique name to give it. So what it will do internally is it will basically join all those things together to create a unique identifier for all the resources. So if you're in the console, you can really quickly see what every individual part of that module relates to in the whole. So you can clearly identify where things belong and where things sort of came from. So if we do a quick plan here, provided we don't have any other issues. So we've going to create quite a few more resources this time, 28 resources to be exact. I'm going to just apply them. I'm not going to ask for approval this time. What we should get at the end, we should get our VPC ID. We should get a list of public subnets. So subnet groups where that are connected to the internet, and private subnets, which are subnet groups which are not connected to the internet, so they're private. So this is typically where you put your databases, because you wouldn't want your databases to have sort of public internet access and things like that. So this is a very standard, typical cloud setup. You have a public subnets which are spanning across multiple availability zones. So you've got high availability at the network level, and you've got private subnets which again span it across availability zones, and they don't have a route to the internet effectively, unless you configure the route tables to allow that. And in some cases, it might make sense. So I see very quick, 28 resources. If I had to do that by hand, I would have probably been here for probably an hour, wiring everything together, and there's no guarantee that I wouldn't have made mistakes. And if we just dive very quickly into the console, you'll see, so we probably ended up in US East actually. So I'll just go to, are we in US East or are we somewhere else? Might be in the US actually. Yes, that looks like it. So yeah, because my local AWS profile defaults to EUS1, so unless I specifically tell the provider, it's going to use the region of my AWS local AWS profile. So in this case, it was Ireland. So you can see here it's created our VPC, and if you obviously go through all the individual options in here, you'll see all the resources that are sort of related to that VPC. So you've got, again, your public subnets and your private subnets. You can clearly see they're all linked together because of the naming convention that's been adopted by the module, so it's easy to find things. And likewise, again, it's propagated a load of useful tags using those same attributes. So we can easily find our infrastructure using infrastructure scope because of these features that you have. And like I say, enforcing and doing this by hand is obviously quite a difficult endeavor. Eventually, it'll fall down. I'm just going to very quickly destroy that before I forget. We'll just finish up the last couple of slides. So yeah, just a code example of what we did there. Very straightforward. Obviously, the module, there's literally thousands of modules out there. I've got a small subset of people that I trust that write good modules. And I tend to use them because I think, a lot of the time, if these problems have been solved, then why shouldn't you benefit from using them? That's the whole point of sort of open source community. and like I said, the modules themselves, the code for them are downloaded into your workspace, and you can go and view them. You can click into them. You can look at the source code. So you've always got visibility of when, you know, if you run into any issues and you felt it was something to do with one of the modules you're using, you could actually go to the modules and actually have a look at the code yourself. Conversely, they're all available on GitHub as well. So, you know, you can go and look on GitHub. So I've got here the module for this VPC we just used. You know, so it's obviously well documented. It's had some security checks applied to it, so it's pretty compliant. Gives you examples on how to use it in different scenarios, and also gives you the API, so it explains all the inputs and explains all the outputs as well. So it's really useful. And again, you know, authors are different. There's a bunch of official modules, if you like, and there's some community providers that I just rate highly, and I would sort of defer to them if they had one before writing my own, because otherwise you're just sort of repeating yourself. And lastly, I just want to cover a couple of remote topics which aren't part of today's session. So remote backends, everything we've done today, we've effectively stored with the state file on my machine, which, you know, as you can imagine, if you're working in a team, isn't great. You know, if I lose my machine, I've lost my state, and I won't be able to recover that state other than systematically going through the cloud provider and re-importing everything through the state management tools that Terraform provides. Provisioners. So what we've talked about is resource creation in the cloud. It does have support for what we call provisioners. So I think Rajiv, you mentioned, if you a provisioner would enable you to, during the provisioner an EC2 instance, SSH into that EC2 instance and run commands, you know, run your configuration management tools to install a certain set of software, or make any changes to that resource before it's sort of made available. State management. So very quickly, I won't get too much into it, but there's a whole state command or subset commands within Terraform that give you, what was I going to do? That's weird. Oh, it's because I've destroyed everything. This would basically give you a tree of all the resources that have been created, and you can sort of interrogate individual resources by their attributes if you want. It also it gives you a recovery mechanism as well. If something goes wrong, you can fix your states by using these state management tools, but it's very rare that I've ever had to use them. Workspace management. So when we talk about, you know, how to manage your infrastructure, what I mean by that is sort of logically separating layers. So, you know, you've got your network layer at the top, so you're looking at your stack. You've maybe got your platform layer, which is all your EC2s, your load balancers, you know, and then you've got your sort of application layer on top of that. Workspace management, I generally, you know, try to look at things, you know, I'll create, depending on the rate at which something changes. A network layer very rarely changes. Your platform layer might change every couple of weeks because you're applying security updates. Your application layer might change, you know, weekly because of people doing deployments. I tend to think about creating and managing my different workspaces in this vein, and again, sometimes that makes a lot of sense because depending on how your team's organized, you might have a team looking after your network layer, you might have a team looking after the platform. They may be the same team, but it just gives you that flexibility in terms of how the organization actually operates and, you know what the team structures look like. And then Terraform Cloud is basically a service offered by Terraform, which does the execution for you. So just think of it as like a build server, effectively. It detects changes in GitHub repositories to your infrastructure. It will apply those changes on your behalf. Obviously, you need to set up the correct privileges. So you have to create some AWS credentials for Terraform Cloud to use in your account. And then it also obviously gives you a nice view of all your workspaces in a nice graphical UI, which can be nice. For small teams, it can work quite nicely. Sorry, one point I wanted to make on the remote backends here is that there are multiple options in where you can store your state file. I typically use S3 if I'm not using Terraform Cloud. If I'm using Terraform Cloud, then they are storing your infrastructure state in their storage engine, whatever that is. Very likely it's on AWS, and very likely it's in S3 anyway, but that is abstracted from you. You still got access to it. It's just that you haven't got to worry about setting up the storage. It's sort of handled automatically for you. And lastly, I just want to just have a very quick talk about some other providers, right? I mean, you know, I've been around long enough to know that there's many ways to skin a cat. So AWS has its own tool called AWS CloudFormation that is similar in the sense that it's YAML and JSON based, and it has its own sort of DSL that's layered on top. I'm not a fan of it personally. I tend to favor Terraform, but then that's what I've been using for a lot of years. I generally, struggle sometimes with the lack of sort of modularity that CloudFormation provides, and obviously the actual provisioner, if you like, the engine, that is not something that is open source. It's closed source, so you really have very little visibility into what CloudFormation is doing when you submit your template to the CloudFormation service. It's an AWS managed service. Obviously, Azure has got something very similar in Azure Resource Manager, and ARM templates behaves very similar to AWS CloudFormation. There are, in the recent years, been a drive to enabling developers to manage the infrastructure in the language that they generally prefer. So as you can see, this can have its benefits, if you haven't got to learn another language. So for example, if you guys are writing Java, you could potentially use AWS Cloud Development Kit to write your infrastructure resources in Java. What it actually does behind the scenes is it compiles to CloudFormation, so it sort of replaces Terraform in that way and gives you the sort of benefits of all the benefits of a programming language to build your infrastructure. It's only been in sort of general availability the last sort of 12-24 months, and I'm still sort of on the fence as to whether it can work. I'm still just far more productive in Terraform at the minute, because I think patterns haven't emerged. Terraform is quite a mature ecosystem. The patterns around using it have matured over the last sort of 10-12 years. Whereas when you introduce new concepts, they take a little bit of time to mature and those best practices to emerge. And if you want to be a trailblazer, then go right ahead. I do play around with these things to sort of try and evaluate whether they could fit into my day-to-day. I even went as far as developing a little Spring Boot version of this for Java to manage your infrastructure almost as a Spring Boot command line application. So it's got some legs. I just don't think it's quite there yet. And it's only for AWS. So if you wanted to be multi-cloud, it wouldn't be a possibility. And Pulumi is another one. So Pulumi basically wraps Terraform. So it's a bit of inception here. You've got sort of Pulumi, Terraform, and then AWS SDK. But what it does do is it exposes you to the same, write your infrastructure as code in the language of your choice. However, it doesn't support Java because it doesn't understand compiled languages. So if you're a shop that works exclusively in Node.js or TypeScript, then this would be an option to you, really easily. And that's it, guys. I'm cautious I've got a meeting in about 10 minutes. I'm definitely gonna have to shoot off, but I think we've got 5 minutes if you guys have got any questions.
I think I'm good. So we'll just go through the repo once, or the repo that we have just explained in this demo. Is this lying on the same repo? Or
it's all in the same proof of concept. I kept it all together so you guys have got easy access to it. So if you want to go in, if you want to download Terraform, you want to play around with it in your own sort of AWS account, go right ahead. They'll work. I'll just quickly fix the one that seems to be broken and just make sure that's there for you as well, so you've got access to all the examples.
Okay, sure.
Yeah. Fantastic. All right. Well, again, guys, thank you for your time. I had a feeling this one might be a little bit running over compared to yesterday's, because it did have some demonstrations and there are always questions around these things if people are new to them. But we'll see you tomorrow, and we'll be looking at the platform layer effectively, which will cover sort of an introduction to Kubernetes and EKS on Amazon.
Okay.